All right, y'all. So today we're actually going to go ahead and start off in Desmos. Okay, and so what we're doing is we're working with solving nonlinear inequalities. Okay, so inequalities, just as a kind of a heads up, right? That's any time you're using greater than or less than these right here, right? So you're working with like greater than signs or less than signs, okay? Or you've even got greater than or equal to, or less than or equal to. So anytime we're working with those and we see different expressions and things like that, that's what we call an inequality, right? Because it's not equal to or the relations like that. Okay. So, all right. Like I said, we're going to go ahead and start off in Desmos. So let's go ahead and look at these two functions right here. So we're going to go ahead and start off with f of x. Okay, and we have a quadratic function. Okay, and what we're doing today is we could potentially graph that, right? We could graph that based on that information. But what we're working on today is just kind of figuring out what values are positive and what values are negative, right? Because sometimes it's actually a little bit quicker for us to do that, and maybe that's the only important part of the the only information that we really need for a particular problem. So that's what we're looking at today, and we can see from this graph, right, because we graphed this equation, that these are the parts that it's positive, right? It's from negative infinity, right? If we were to continue on all the way to negative infinity, it would be positive. And then when we hit this point, right, at -5, after that it is negative, right? And negative as in under the all my y values are negative. Okay, and then we continue here, and the function begins to be positive. All right, so that is going to be helpful for us in times, right? So we've got to be able to do this particular situation, right? What we're trying to find is, when is this function positive, when is it negative? And depending on the problem, right, it's either going to be either greater, right? This is all the stuff that's greater than 0, or less than 0. Okay, so that's where this comes into play with the inequalities. So you could do one with a polynomial, okay, or you can do a rational function, right? This is a rational function here. Same situation, right? Where is this function positive? Where is it negative? Well, in this particular graph, right, it is negative down here, right? And again, by negative, I mean y values that are negative. Okay, and then it reaches this point of x, which is again at -5, and then it becomes positive. Okay, and then but then down here it becomes negative again, and then positive again here. All right, so we're going to talk about how to solve for that. And again, the question might ask, when is this function greater than 0? Well, the answer would be, when is it greater than 0? That would be from this x, right, that x value, to this x value, it is positive, right? And then additionally to that, from this x value and on, it is positive, all right, again, above the x-axis there. So that's what we're working with today. When we kind of lose sight of what we're doing, just remember that there is also a graph visual way to do this. It's just at times, once you get used to it, it's actually quicker than graphing it, and that's why we do this particular method at times. All right, so let's go ahead and begin. We're going to do 4 examples, okay? And I have a sheet, right, that has the nice and neat laid out steps, and we're going to be following these steps. I know it's a big page, but it's mostly because it's just big font. So we're going to be following these steps throughout our problem here. Okay, so let's go ahead and start with number 1. All right, and so what we're going to do in number 1 is we are going to do, let's do, it is, I have that written down here. Where'd they go? Pause it. All right, I'm back. So we're going to go ahead and do this one right here. This is x squared plus 4x minus 12. We're going to find what that is greater than 0. All right, so we're going to use these steps, especially for the first few, to kind of guide us. All right, so use algebra to get a 0 on one side of the inequality. Now, let me just go ahead and say that we already have this done here. Okay, it's possible, and what I mean by this is that maybe like the 12 was over here, right? So if I added 12 to both sides, I would have a 12, right? And then it would be gone over here. If it doesn't already have the 0 somewhere, then you've got to swing everything by by adding and subtracting to get it all on one side. So you can have that 0, because that 0 is really the key part, right? That's determining is it positive or negative for our problem. Okay, so factor the polynomial if necessary. That's what we're going to do first. So let's go ahead and factor. Here's our classic like trinomial factoring, right? And we're going to keep the greater than 0 part. We're going to think of numbers that we can multiply to get negative 12, right? We know one of them is going to be negative, one's going to be positive. So think of numbers that we can multiply to get to 12, but then add up to 4. Okay, so again, hopefully we're getting better at these. But in that particular one, it's going to be 6, right? And then 2, right? So negative 2, 6 times negative 2 gets me that negative 12. And then 6 plus negative 2 here gets me that 4x. Okay, so we've got our factoring first. Okay, now find the boundary points. Now, boundary points is a big vocab word for this particular lesson, but the boundary points are essentially where either the numerator or the denominator equals 0. Okay, where it's equal to 0. All right, so notice we don't have a numerator and denominator. We will eventually have one, but we don't have one for this particular case, right? We just have the polynomial, right? And it mentions here if it's just a polynomial, you will not have a numerator or denominator. Okay, but we're still going to set that part equal to 0. So this is the points, right? If we wanted to find our boundary points, okay, to have our work organized, okay, if we wanted to find the boundary points, we would set x plus 6 equal to 0, okay, and then we're going to get x is equal to negative 6. So negative 6 is going to be a boundary point, okay, x minus 2 equals 0, x equals 2, that's going to be another boundary point. Okay, so my two boundary points for this particular one are x equals negative 6 and positive 2. That's step 3. Step 4, we're going to draw a number line with each boundary point plotted on the number line. Okay, so classic number line here, we're just going to draw a horizontal line, and then we're going to plot negative 6 and 2. Okay, for me personally, the only ones that I plot are those boundary points. Now, you can fill it in with other points if you really wanted, but in my opinion, it's going to make things a little bit confusing just because you're going to have a bunch of intervals here. And I just want to stick to just the intervals that I have, right? I don't want extra information. I just want to have the exact information we need. So, negative 6, positive 2. Doesn't even have to be drawn to scale, okay? But you can notice now that we have 3 sections, right? We've got this section negative 6 and below, right? And then we've got this like middle section, and then we've got this third section over here, right? And this is 2 and all the way up to positive infinity. So that's step 4, where we're drawing our number line. Okay, step 5, determine the sign for each interval created by the boundary point. So again, we've had 3 intervals for this particular one. We're going to do this by testing out values that are within the interval. All right, so I am going to call this f of x. I'm just going to understand that anytime I'm referring to f, I'm referring to that function right there. Okay, maybe we can just write it just in case, right? That's going to be my f of x. Okay, and now what I'm actually going to do here is I'm going to plug in values that are within this interval. Okay, then I'm going to plug in values that are within this interval. Then this one, and since we have 3 intervals, we're done. Okay, so let's go ahead and plug in a interval for negative, we're going to plug in a number from the interval into f. So f of negative 7. All right. Now, here is the interesting part. Okay. All we need is to determine the sign. We need to determine if this number, f of negative 7, is positive or negative. That's all that actually matters here. So instead of actually doing, negative 7 plus 6, which is negative 1, right? Instead of actually doing negative 1 times whatever this is when you plug it in, we could get a number, but that would be kind of extra thinking. All right, so what we're going to do, we're going to do like a sign activity. Okay, so this is f of negative 7. We're going to plug it into the factored form here. Okay, so this is f of negative 7, so we've got negative 7 plus 6. All that we want to talk about here is that positive or negative? So, negative 7 plus 6, okay, well, that's going to be negative. So I'm just going to write a negative here. Understand that this is technically equal to negative 1, but all that matters is it's negative. We're just it saves us a little bit of time, so there's just no point to do those operations because all we're looking for is if this value is positive or negative. Okay, so we've got negative here, and then times, Okay, well, let's see. Negative 7 minus 2, is that a positive or negative value? Well, that's going to be another negative value. Okay, so what we have here is we have a negative number times a negative number. Well, what is a negative times a negative? That's going to be a positive. All right, and you could test me out on this. If you did that same thing with any number that is less than negative 6, right? If you did that with negative 20, you're going to get a negative times a negative. Okay, if you do that with negative 2,500, you're going to get a negative times a negative, right? So you end up with that sort of situation here. So all we need is that it's a positive, all right? And we're going to label it, actually. Like, I like to just put it here. Once I found that this is positive, I'm going to put my positive right there in that interval. Cool. Now we got to do the same thing for the other two sections. Okay, so we've got, I like to pick 0, okay, or some people might like to pick 1, but if I've got an opportunity to do f of 0, I'm going to do f of 0 to make my life a little bit easier. So I've got 0, and I'm plugging it into here. 0 plus 6, that part is going to give me a positive, okay, and then 0 minus 2, that part is going to give me a negative number. So I've got a positive times a negative. Well, that's going to give me a negative, okay, and that's what I'm going to put here. And then last one, the 2 and on. So I don't know, let's keep it simple. Let's do 3. Okay, so 3 plus 6, that's a positive. And then 3 minus 2, that's a positive. Okay, so we have a positive times a positive. That is going to be a positive right there. Okay, so we have now determined the sign for each interval created by the boundary points. Step 6. If the inequality was in the form f of x is greater than 0, or f of x is greater or equal to 0, okay, then the solution is everything positive. Cool. Let's go ahead and read the next one first, and then we'll determine which one we have. If the inequality was in the form f of x is less than 0, or f of x is less than or equal to 0, then the solution is everything negative. All right, so we determined what these values over here were. They're positive y values, and then negative y values in between here, and then positive y values here. Okay, so which one are we looking at? Well, we're looking for when f of x is greater than 0. Okay, so then in this case, my solution is everything positive, because I'm looking for when it is bigger than 0. Right? So I've got these two intervals right here. So my solution would be all these numbers, right? Everything that's less than negative 6, but also greater than 2. So there's two sections that would give me numbers that would make this a true statement. Okay, step 7, let's just go ahead and check everything. If the inequality used is a less than or equal to or greater than or equal to, I don't have that, right? I don't have that here. So we can skip this step for now. But you must also include the zeros from the numerator in the interval. This is because the values that are equal to 0 must also be included. Now let me just go ahead and state that it's not just the numerator. If it was just a normal polynomial, you also have to include just those values that would make it equal to 0. Okay, and we'll do an example on that in the next one. Number 8, keep in mind it is possible to have no solutions or infinite solutions. Okay, it's possible to have the entire function positive or greater than 0. It's also possible to have the entire function less than 0. Okay, so it's possible that you don't have anything in the solution, or it's possible that everything is in the solution. Cool. And we will also run into one that has that as well. All right. So number 1, now we're actually going to write our interval. Okay, because our interval is essentially it's the solution, right? And we mentioned earlier that this was our solution. So in order to write this, okay, we're going to use our interval notation, right? So everything that is negative infinity up until negative 6 is positive. So we're going to include it in our solution. But it's also if it is 2 and up. That is our answer. Okay. Now, again, what these are referring to is this is all these numbers, and we've got all these numbers. Okay. So just to give you a sketch of what we're looking at, just to give a more visual, let's go ahead and do it on Desmos. I've got Desmos handy. So x plus 6, x minus 2. X plus 6 minus 2. Okay, and we'll graph it. Okay, and let's zoom in so we can get some of these values. And so what we see here, just to compare, right, is that everything from negative infinity to negative 6, okay, so all this is positive, okay, that's good, and this is the negative interval, and then after 2 and above is positive. So just to double check, right, you can do that as well in your work here, that there's nothing wrong with that. It's just really what I'm going to be testing, right, is this part, but, you know, this is also just kind of a way to double check, okay? That's the visual graph way of basically doing what we just did. All right, so that's number 1. That is solving nonlinear inequalities. Okay, number 2. Number 2 is, you're welcome, it's factored. And this time we're going to have less than or equal to 0. Okay, so we've got a less than, kind of change it up a little bit. We've also got a, or equal to part in there. Okay, so if we're following along, I'll probably read through these a little bit. I'll read through them, but I'm not going to point them out as detailed as I had before. Make sure you have it handy, though, so you can remember and replicate this process. Okay, so it's factored. We've already got the 0. Now we're finding the boundary points. Okay, so the boundary points, maybe we can skip this. Hopefully we've gotten pretty good at it. But my boundaries are going to be negative 2. Okay, negative 2 here. It's going to also be 4 because of this one. And then negative 5 because of that one. All right, so those are my boundary points. And then the next step will be to draw a number line. So we're going to draw our number line. And we're going to include each of these boundary points. I don't like to include anything more than those boundary points. And so you might want to organize these into numerical order, right? So negative 5, negative 2, 4. Okay, just in case, right? So negative 5, okay, 2, 4. And again, it doesn't even have to be drawn to scale. We're just sketching it out. We're just trying to figure out our information from each of these pieces, right? We're evaluating that f of x, and we are seeing if it is positive or negative at those values. So that's our goal. So we're going to go ahead and start plugging things in. Okay, we want to plug in things from each interval. So I need something less than negative 5, just to show you, right? Let's just do negative 10. Okay, f of negative 10. Now, notice we have 3 this time. Okay, so it's going to be a sign here, and a sign here. Okay, so for each one, we're going to have to determine what we have. So negative 10 plus 2. Well, we have it's super high negative number, not big enough to cover it. All right, so negative 10, only adding 2 back, that's going to be a negative. Okay, negative 10, and we're subtracting even further, definitely a negative. Okay, and then negative 10, and we're only adding 5 back, so that is also negative. Now, if you wanted here, okay, you could kind of split these, right? So what's a negative times a negative? Well, a negative times a negative would give me a positive, and then a positive, right, because that's a positive, times a negative, right? The entire thing would be a negative, okay? So I like to circle it when it's like done, okay? When it's done here, right? Or maybe you just know a negative times a negative times a negative is a negative, okay? But you can split it up, right? 2 negatives get you a positive, so this part positive, and then that last negative, don't forget that, okay? That's f of negative 10. I need a value in between. I'm going to use my 0. So 0 plus 2, that's positive. Then we've got 0 minus 4, that's negative. 0 plus 5, that is positive. All right? So I've got a positive times a negative. Just this to the left of my hand, that's a negative. So a negative times a positive. This is going to be a negative. And I feel like I made a mistake. Plus. I'm going to pause it just for a sec. Yep, I found my mistake. So I accidentally made this a positive. Needed to make that negative. Okay, so I can't use 0 here. All right, I can't use 0 here. I'm going to have to use something within that interval. So I'm going to use negative 3. Okay, so negative 3. Now let's test it out. Negative 3 plus 2. That is still going to give me a positive. Okay, negative 3 minus 4. Negative. So that one still works. What? Ugh, okay. This first one is the negative, right? So negative 3 plus 2, not quite positive. Not quite positive. Come on. All right. Negative there, so that's a negative. Okay, now we're good. Life is back to normal. Negative times a negative, that's a positive. Positive times a positive, that's going to be a positive. Okay, cool. All right, so positive here, and that's where we're getting at. Okay, and then we want to pick another value. Now we can do the 0. Okay, and we pretty much did that already, but we'll go ahead and do it again. 0 plus 2, that's a positive. 0 minus 4, that's a negative. 0 plus 5, that's a positive. All right, and that is indeed going to get you a negative, right? Positive times a positive, so you can kind of delete one of those, right? Positive times a positive, and then negative times a positive, that's going to get you a negative, okay? So you can kind of use some tricks, and you can kind of like eliminate a few of them, right? Again, like the trick I kind of did here was a positive times a positive makes a positive number. So now I'm just left with one positive number. Remember, you can multiply in any order, and so that's why we're able to do that there. Last one, f of 5. Okay, f of 5. So we've got positive up top. Okay, on the second one, 5 minus 4, that is also a positive, and then 5 plus 5, positive, positive, positive. That's going to be all positive. Okay, now one thing I do want to note, you can kind of combine, if you can get a little fancy here. Okay, I'm not going to practice it this way, but you can get a little fancy here, and once you kind of, like, remember, we've been graphing these guys. Like, this is a polynomial. This is still a polynomial. And if you remember with multiplicities, okay, if you remember with multiplicities in our graphing of polynomials, right, what are the multiplicities here? 1, 1, and 1. That means they cross the x-axis. In other words, that means they change the sign at that point. So, food for thought. I'm not going to practice it that way because I think this is good practice using these like sign equations. But that is kind of a trick. If it's all multiplicity of 1, then the signs will always change, right? Because it is crossing the x-axis, which would be going either from a negative to a positive or going from a positive to a negative. Food for thought. Anyways, this problem is where it is less than or greater. All this is less than or greater to 0, or greater than 0. So just so we know, just so we're clear, so we're working with this option right here. So the solution is when it's negative. Solution is when it is negative. Now, note number 7. Okay, we've got to include those values. So including those values is going to be like putting a bracket. Okay, remember the bracket is where you're saying that is part of the solution. Parentheses is where it gets very close but doesn't quite touch. Okay, so we need to include the boundary points when we can. All right, when we can. So we're looking at all the parts where it's negative. Okay, so it's negative here and here. So within this and within this. So negative infinity all the way up until negative 5. But do we include it? Okay, yes we do because it's equal to, right? Because at negative 5, right, if we were to plug in negative 5 here, it's going to be equal to 0. Okay, this entire thing, right? Because we get negative 5 plus 5, that's 0. Doesn't matter what these two are. It's 0 times a number times a number. That's going to get me 0. So I have to include it using the bracket. Okay, and then the second one, again, it's this interval, but I've got to include negative 2 and I include 4 because those would get me zeros. Okay, so I'm putting a bracket, negative 2 all the way up to negative 4, and those values are going to give me negative, are going to make this true, make this a true statement. Okay, number 3. All right, now here's our really one and only example where it's a rational. Now, the truth is you don't change it too much when it's a rational function. Okay, so that's really why we're only just doing 1. It's super, super similar to what we were previously doing. Okay, so on this next one, x squared minus 5x over x squared minus 9, and we're going to do greater than or equal to 0. So, same situation. We've got to check if it's factorable first, and this is factorable on the top and the bottom. So I'm going to go ahead and write it into factored form. This is your classic GCF. Right? I've got an x here and an x here, so I got to pull out x. So I've got x here and then x minus 5 on top. I'm undistributing, right? If I were to redistribute, right, x squared minus 5x would give me that. Okay, and this is your binomial. Notice I don't have an x. Maybe some people get confused when they see that. Okay, I can't tell what they're looking at. But remember, this is x squared minus a perfect square. This is that classic example where you've got x plus 3 and x minus 3, where that middle term cancels out. Less than or equal to 0. Boundary points. That's my next step. Okay, now the boundary points, the only change here, all right, is it's where either the numerator or the denominator equals 0. So this time you got both, right? It's where the numerator equals 0 and it's where the denominator equals 0. Okay, so you've got multiple boundary points. Let's talk about that up there, right? That is going to be 0. So that boundary point, because of that x, it's going to be 0. Because of this, x minus 5, well, what's going to get me a 0 here? The number -5. No, the number 5. Just testing y'all. And on the bottom, x, that one on the left, is going to give me -3 as a boundary point, and then here, +3. So maybe it helps, again, to reorder them. So we've got -0, 3, 5. All right, and put them on the number line. Okay, we've got a lot of sections here. All right, just something to keep in mind. So anyways, -3, 0, 3, 5. So you end up with 1, 2, 3, 4, 5 sections that we need to test. All right, and let's go ahead and do it. All right, maybe we'll get started and then we'll see the pattern. Okay, so maybe we'll use that. Actually, no, we're not. We're not going to do that. I changed my mind. All right, -4. -4, and so we're going to go ahead and test that. And you're always going to use that factored form. Okay, you're always going to use factored form here. Okay, and we're going to treat this as my f, right? This is still your f, but this is factored form. Factored form is going to be way easier to find the sign. Okay, because you're multiplying and dividing with factored form. Okay, and so it's way easier to think about multiplying and dividing negative numbers and positive numbers than it is to add and subtract. Not fun, right? Because multiplying and dividing, it's very straightforward. It's, positive times a negative equals a negative. Positive times a positive equals a positive. Those kinds of things. So it's the same pattern each time. Adding and subtracting is a little more nuanced. So anyways, -4. Okay, we got a negative up top. Okay, and we're doing the same process, guys. We're gonna literally write the fraction too, right? The dividing. But -4, that piece is a negative number. That's where I'm getting this. And then -4 minus 5, well, I don't know what it is, but it's a negative number. That's all that matters. Right? I'm not thinking about the number. I'm just thinking if it's positive or negative. -4 plus 3. Okay, -4, but we're only adding 3 back. That's going to be a negative. Okay, and then over here, -4 minus 3. Okay, so even going further negative, still negative. Okay, now you could simplify this in a lot of different ways. The way I'm going to do this is on top, negative times a negative. On the bottom, negative times a negative. Positive times a positive. That is a positive. Okay, cool. Next one, f of -1. Okay, we'll go through these a little bit quicker. All right, f of -1. Now we're within this interval, so it's a negative because of that x, and then we've got -1 minus 5. That's a negative. -1 plus 3. That's a positive, and then -1 minus 3. That's a negative. So on top, I've got a negative times a negative. That's a positive. Positive times a negative. That's a negative. And then positive divided by a negative, that is a negative. That's what we get here. Continuing. Maybe we'll, I'm going to keep going down. Okay. 0 in between 3, right? So I'll go with +1. Okay. X, positive, 1 minus 5, that is negative. 1 plus 3, that's positive. 1 minus 3, that's negative. Okay? On top, positive times a negative, that's a negative. Positive times a negative, that's a negative. Negative over a negative, that's a positive. In between 3 and 5. You could do 3.5 if you wanted, or you could do like 3.75, whatever. Yeah, as long as it's in between, but I don't know why you would do that. Pick an easy one. 4 is probably your most basic one there. We need to zoom out, and we can't. So I'm going to move over. or we're just going to squeeze it in here. Okay, 4, positive. Okay, with that x, right, you're just plugging in 4. 4 minus 5, that is negative, right? 4, and we're subtracting 5, so yeah, it's going to go into the negative side. 4 plus 3, positive. 4 minus 3, positive. Okay, so on top we've got a negative over a positive, so this is going to get me entirely a negative. And then last one, something greater than 5. Let's do f of 10. Why not? 10, positive. 10 minus 5, still positive. 10, yeah, positive, positive, all around. Boom. Okay, now we have the signs. Similar situation, right? The only difference, right, is where you have that dividing aspect of it. Okay, it's just the rational aspect of it. So maybe a little more numbers, something like that. But for the most part, very similar to what we did before. Okay, so on this one, since it's greater than 0, I'm looking for when it is positive. So those are going to be my winners right there. And let's go ahead and do the intervals. So negative infinity to negative 3. Question is, do I put a parentheses or a bracket? Well, because of that equal to, I've got to put a bracket. I always put parentheses for negative infinity. And then union is what that stands for. I don't know if you knew that or not. It stands for union. 0 to 3. And then 5 and on. That is your solution there. Okay? That is your solution. One more. Promise it'll be quick. Probably the quickest one. Okay? Number 4. Okay, number 4. So we've got x squared plus 6x plus 10 less than 0. Less than 0. Okay, so first step, well, make sure 0 is all on one side. We've got the 0, so we're good. And then factor the polynomial. All right, so we're going to check if we can factor it. All right, and what we see is that this is your classic trinomial. Okay, and we look at this 10. All right, and if we were to think of the factors of 10, right, you got 1 and 10, right, you got 2 and 5. Problem is none of these add up to 6, so this is actually unfactorable. Okay, this is an unfactorable problem. All right, so if it's unfactorable, that means it doesn't intersect the x-axis. So it's either something like that, or it could be like that. Okay, let's go ahead and get this out of the way. It's going to be like this. Okay, because there's not a negative out in front. So since this is positive, it's going to look like that, something like that, where it doesn't intersect the x-axis. So I'm not even going to say that as an option. If it were negative, right, it would be that. Okay, so we know as a quick sketch, it looks something like that. I don't know where it is. It could be over here. I'm not sure. Don't really care. Okay, but what we want to do here is we just want to test one value, right? Let's stick to what we were kind of doing before. Let's test a value, right? Just in case. Okay, just in case something funky happens. I like to test out 0. Okay, that's just what I stick with. So I'm going to go ahead and plug it into standard form. It's not factorable, so I'm going to plug it into standard form. So 0 squared, okay, plus 6 times 0, that's still 0. And then plus 10. Okay, so I end up getting f of 0 is 10. So whatever this is, right, and let's just say this is a positive. Right, it's a positive number. Okay, 10 is greater than 0. Okay, so what we just found is we found that at 0, it equals 10. So if we were to extend it, right, it would be like up here. Okay, so at x equals 0, my value is 10. So it's positive. Okay, I know that it is entirely positive because of this. So is it true that if I have a positive number, that it could be, that 0 would be greater than a positive number? Or in other words, is a positive number ever less than 0? Is that a true statement? No. The answer is it is never a true statement. So since it is a false statement, this is no solution. Okay? It is never possible for this polynomial to be less than 0. It's always going to be greater than 0. Okay? So that's number 4 there. Now, one thing to keep in mind, guys, if this less than sign was switched to a greater than, okay, it's actually always going to be true, okay, which would be all real numbers, all right, which would mean, negative infinity to positive infinity. Food for thought, okay? So that is our lesson today. That is solving nonlinear inequalities. I think these are kind of fun, if you ask me. I like doing these. It's fun with the little signs, and really it's like, it's incredible to me how much you can pull from a polynomial like that. Like, we did all that work just to see if it's positive or negative. So kind of like detective work, right? It's like we found all that information without actually graphing it. Like we found it a different way, like using the numbers, and that is just super cool to me. I don't know. This process comes in handy at times, especially in calculus and even further in math. So it's a neat deal. It's a fun process. So, anyways, that's all I got today. You guys take care. Hang in there. Y'all keep working hard. Y'all are awesome. That's all I got. Take care. Bye.